Welcome back, ladies and gentlemen, to the Maclaurin and Taylor series introduction. In this episode, we will be doing the Maclaurin and Taylor series shortcut, or it's the shorter cut. It's not going to be super short, but it definitely makes your life a little bit easier. And so we're going to, instead of solving for actual terms this time, we're going to solve for general terms. And by solving for general terms, we should be able to come up with a polynomial that can fit a pattern that will allow us to derive things quickly. At minimum, it's going to get rid of this step here that is in blue here. You're not going to have to do this every single time after watching this video. And so, with that in mind, guys, if you need to pause and copy this polynomial derivation down, that we can start making some associations. But if you're ready to move on, we will just move on. I'm going to go and just, again, solve for general pieces here. F of 0 equals P of 0. F prime of 0 equals P prime of 0. F double prime of 0 equals P double prime of 0. F triple prime is equal to P triple prime. And then I always seem to run out of space here, actually, but not this time. F to the 4th of 0. Just kidding. I am going to run out of space, but that's okay. We can deal with that. Okay. So from here, let's go ahead and just figure out what these things are. F of 0, well, F of 0 is whatever F of 0 is. I'll just call him F of 0 because that's what he is. And if I plug 0 into all the x's for P, I'm going to get A. Here, I'm going to get F prime of 0 equaling B. And if you just keep on solving like the way we have, you should get F double prime of 0 equaling 2C, which means C will equal F double prime of 0 over 2. And again, this F of 0, F prime of 0, F double prime of 0, these are all constants. So remember, at the end of the day, we're going to take these constants and plug them back into the values of A, B, and C. And I think at this point you might be beating me already when you say F triple prime of 0 over 3 factorial is equal to P is equal to D, and then F fourth derivative of 0 over 4 factorial is going to be equal to E. So how does this help us move a little bit faster? Well, in general, what we can say then is we can make a big generalization about this polynomial here, and that is that P of x will be equal to, instead of A, I'll call him F of 0. And instead of B, I'll call him F prime of 0, x. And instead of C, I'll call him F double prime of 0 over 2 times x squared. And then down the chain we can go. Over 3 factorial x cubed plus F fourth over 4 factorial x to the 4th plus, and you can guess what this is going to be. It's going to be over 5 factorial x to the 5th, and down the chain we can go. So if you can kind of commit this a little bit to memory, then it'll help you move a little bit faster through these Maclaurin and quite frankly Taylor series. And I know we haven't talked about Taylor series at all in the past couple of videos, but this shortcut applies to the Taylor series as well, and I will show you how that works. Give me a second, I'm going to pause, and we're going to do an example using the shortcut. Okay, here's our example. F of x equals cosine x. So I'm not absolved of having to derive this a few times. I want to be able to do that just because I want to be able to start plugging things into the actual function itself. So I'll go and just take the derivative a few times. If you want to go and fast forward, you can go ahead and do that. And I'll go and just derive up to maybe 6 of them. And that because it's really not terribly hard. And then the 6th derivative here will be negative cos x. I'll clean that up a little bit. Cos x. Okay, so using this idea, this formula here, this shortcut into this function here, we're going to represent cosine as a polynomial function centered at 0 via a Maclaurin series. So from here, F of 0, well, F of 0, I can just plug that in. He's going to get me 1. Piece of cake. F prime of 0 is going to be what happens when I plug into F prime of x here. Well, that's going to be 0 because sine of 0 is nothing. Now this plus F double prime of 0 Well, f double prime of 0 is going to be this negative cos x. Well, that's going to be negative 1 over 2, but in this case, I'll just call him 2 factorial. I'll stick him as close to the letter of the law as possible. And that's going to be multiplied by an x squared. Plus f triple prime of 0, well, that's sine. Again, we're back at 0. And then plus f, the fourth derivative, is going to be cosine, so that's going to be 1 over 4 factorial x to the fourth. And if I clean them up a little bit, I think you might be able to start seeing what this pattern is going to look like. So p of x is going to look like 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the fourth. If you notice, the fifth derivative is going to go away, it's going to become 0, but the sixth derivative would become negative at 0, so negative 1 over, you guessed it, 6 factorial x to the sixth plus 1 over 8 factorial x to the eighth, and down the chain we go. So I think it's a little bit shorter. It means you don't have to keep deriving those polynomials over and over. You just have to keep deriving your function. And usually the derivatives will be pretty easy, until they're not. And we'll do that when we get to manipulations of these things. But while we're talking about manipulations, if you want to reference the original, the video before this about sine, the original sine, the sine represented as a polynomial looks like this. It looks like this. X minus 1 over 3 factorial x to the third plus 1 over 5 factorial x to the fifth minus 1 over 7 factorial x to the seventh plus dot dot dot. We saw that happen in the last video. Now, this p of x here, well, he's really cosine, right? So cosine is really this guy. And I want you to start seeing if you can establish a relationship between these terms here. What is x's relationship to the number 1? What is 1 over 3 factorial x cubed's relationship with 1 over 2 factorial x squared? What's the relationship here, and then down the chain we go? Maybe something to think about. Maybe I'll go over it later on in another video, but if you can see a connection here between the terms, and then if you can make that same connection between sine and cosine, you're already halfway there when it comes to manipulations of Taylor series and Maclaurin series. Let's do another example with the shortcut, of course. Let's do a straightforward one. F of x is equal to e to the x. Let's go ahead and put some instructions on here. Let's go ahead and do the first 5 non-zero terms, and we'll use a Maclaurin series. We'll use this formula again. And so f prime of x is equal to e to the x. Now this one is pretty straightforward. F, the kth derivative, is going to be e to the x. We know that. There's nothing new here. And so I can just apply that into this formula. So what is f of 0? Well, that's going to be 1. And then f prime of 0x is going to be 1x plus x squared over 2 plus x cubed over 3 plus x to the fourth over 4 plus x to the fifth over 5. And those guys deserve factorials. My apologies. And then we just keep on going down the chain. So hopefully doing this will allow you to move a little bit faster. If I wanted to make this like a sample AP question on you, here's what they would probably do. They'd probably give you this thing to start off. They would start you off with this thing. And what they would say is they would say, okay, we want you to derive this function here. 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the fourth over 4 factorial plus dot dot dot. And they'll say, all right, do this at x equals 2. Your job is to say, hey, I recognize this, what's known as a power series. This is what's known as y equals e to the x. This piece here is telling me to take the derivative of that function. So that means that dy over dx is equal to e to the x at x equals 2, giving us e squared. So that's how a problem like that would jump out at you on the AP exam. Hopefully you found this video helpful. I encourage you to do some of the homework. Make sure you attempt the shortcut if you want. And we will see you, and I will finally get to Taylor series in the next video. Of course, as always, leave any comments or questions in the comments section, and we will see you in the next episode.